It is riding below, if you will, attached to, but below its liquid oxygen and hydrogen liquid fuel tank.
This is the way that it goes into space, and during a variety of times during the trip, they will be riding upside down, and it is something that is easy to confuse people with, but due to the methods that we have to go into space, this is the safest and the best way to get there, with the huge external tank, the fuel tank, on top, which will remain there until they make almost the first orbit.
Achieve a single-engine landing at Banjul, if that were to become...
If you will look in the right-hand corner of your screen, we give you the down range of approximately where the Discovery is in relation to the Earth's surface. In addition to time from liftoff, it's plus 6 minutes and 40 seconds, the speed in miles per hour, and the next major event, which is, as we mentioned, is the main engine cutoff to come at about the 8.5-minute mark. Jeff?
Let's also remember at MECO, we will be in space. We will not actually be in orbit until we fire our orbital maneuvering engines 45 minutes after launch. But we will have gotten through surely the most risky part of the whole mission.
Jeff, it's incredible to believe that it's now traveling at a speed of about 12,000 miles per hour. Its top speed, when it reaches its top speed,
about 17,000.
About 17,000 miles per hour. Well, everything looks and sounds excellent at the moment, does it not, Jim?
Even if they lose 2 engines, they can still make it to orbit.
Another milestone passed. Even if they were to lose 2 of the engines now, they could still make it into orbit.
The other thing that's happening now, we have full thrust out of the engines, but because so much fuel has been burned off and it's lighter, the acceleration has built up. The crew is being pressed down into their seats with a force of 3 times Earth's gravity, and in order to avoid exceeding that, the engines are actually starting to throttle down. Let's remember, these are the first rocket engines of this size that have ever been able to throttle down.
As we wait for main engine shutdown, let's go to Peter Van Sant, who was watching with thousands of other people here at the Cape. Peter?
Dan, NASA just scored the winning touchdown late in the 4th quarter with these folks. There was tremendous cheering, excitement. Despite the fact we're about 13 miles away, you could still feel some of that vibration, and the sound was tremendous. I've got a couple of people here who just watched the launch. What'd you think?
Unbelievable. It was so great. I mean, I almost feel like crying. I'm so proud to be an American. I've been here all night long. It's fantastic. It's unbelievable. Words can't describe it. For all the people sitting back home, you know, in their living room watching it, it's nothing like being here watching it. It's just right over there. Unbelievable. I'm so proud. It's great.
We're back in space.
Thank God. All right.
How about you?
Yes, unbelievable. I'm from England, and, well, just to be here is absolutely a miracle. You know, to see that go up was something I've always wanted to see, and I'm glad I did.
Tremendous. Back to you, Dan.
Wow.
Lots of enthusiasm.
Thanks, Peter. Now, let's set the scene for you. Everything looks and sounds perfect, as best anyone can determine. The launch has reached the point where even if the Discovery should have 2 engines fail, they could make orbit. We're just told they are in orbit. They have just now reached orbit, and what good news that is.
Altitude. Standing by for external tank separation.
They're going to drop the large external tank now, which will eventually fall back down into the ocean.
Waiting for word that they've done that. Always a major moment when the external tank separates from the shuttle itself and leaves the orbiter there in orbit.
And this is an incredible...
Discovery, your go for APU shutdown on time.
That means Mission Control is satisfied that they can stay in orbit. So they're going to shut down their hydraulic systems. They're no longer needed.
Power to operate the aerodynamic services
Bottom line
and
this
to
time,
gimbal the
Dan,
engines.
we've got a great flight.
Well, on that line, that bottom line, at this moment, we've got a great flight. Discovery is in orbit. Let's pause for this message.
Oxygen and dumping it into the cabin.
Well, good news, Discovery is in orbit. Remember that you have the orbiter itself. These solid rocket boosters dropped off at about 150,000 feet. It's already jettisoned its liquid fuel tank, and now what you have in orbit is the orbiter itself. What good news. Leslie Stahl was among those watching the launch with a classroom full of people in Virginia. Leslie?
Dan, I'm here with the dreamers, young high school science students still dreaming about going into space themselves. They're working on a science project that NASA has already approved to go up as a student science experiment in a future Challenger flight. But I want to show you, we taped their faces, their expressions, their excitement when the launch went up. I wonder if we can roll the tape and show you their reaction. Dan, as I said, they're the dreamers, and I asked them right before if they all wanted to go up in space, and all but 2 people raised their hand and said they did. I'm standing here next to their teacher, who was Ron Fortunato, who was one of the finalists in the Teachers in Space contest that Krista McAuliffe won. Ron, what were your reactions and your feelings when this was a successful launch today?
Oh, it was just perfect. The launch went up, and I can remember clearly 2 years ago we were sitting here watching it, and I saw clearly today what the future of our space program is, and maybe just as important, what the future of education is for these kids.
Terrific. Krista McAuliffe said, "I touch the future, I teach." These kids are going to be watching on a computer, tracking the shuttle as it goes along, and they're also, by the way, Dan, tracking the Soviet space station, and Ron told me that they're both, or were at least at one point, both at the same longitude. Back to you, Dan. I'm with the dreamers.
Thank you, Leslie. Aren't we all dreaming today? Joining us now is Michael Collins, who was on board Apollo 11, the launch that went to the moon. I know you're excited about what happened here today. Your impressions?
That was just a wonderful launch, Dan. I've never seen a finer one. Of course, waiting around an extra hour or two doesn't hurt things either. Your feeling of anticipation.
Here's a tape replay of the liftoff.
Liftoff. Americans return to space as Discovery clears the tower.
Roger, roll, Discovery.
Crew confirms roll program. Houston now controlling.
Michael, as you saw this happening, Michael Collins, what were you thinking? At this particular moment, they were just about reaching the point, soon to reach the point where we had the terrible Challenger disaster. It must have gone flashed through your mind.
65%.
I think so, and especially the mind of the crew, of course, as the same terminology in the air-to-ground, ground-to-air voice was used, so they were hearing the same messages, of course, that the Challenger crew heard. But as I was watching it, I was thinking back to Saturn V days and sort of looking comparatively at the 2 machines. They're quite similar but quite different. This one gets up and goes a bit quicker than the old Saturn V used to do.
Ending by to see engines begin to throttle back up at about 59 seconds.
Well, what a sight this was to see it disappear
Mark 1
intact
minute. Velocity 2,300 feet per second. Altitude 5.9 nautical miles downrange.
The main purpose of this flight to get out the tracking and data relay system satellite. This is a $100 million satellite, identical to the one destroyed aboard the Challenger. That's the main purpose of this mission. Other purposes are what?
Well, they'll do a number of scientific experiments during the 4 days that they're up there, but as you say, the deployment of this communication satellite will allow NASA to save a lot of money in that it won't need the extensive network of ground stations that we used to require during Apollo days. 2 of these satellites in orbit will give NASA almost continuous coverage. So just as satellites are very much a part of our lives, communication satellites allowing us to see the Olympics, so NASA is using them to best advantage.
And Jeff Hoffman, very briefly, the astronauts are in orbit now. They haven't made one complete circle of the Earth. What are they thinking? What are they doing?
Right now, they are busy as anything. There's a lot of things to do to get a shuttle, once it's in space, ready to stay in orbit. That's what they're working on. I'd like to say one thing. We just heard our launch director thank the launch crew, and I know something that the astronauts are very aware of is they may be on top of the pyramid, and they're the ones in space, but there's thousands of people who have done an awful lot of work to get them there, and they appreciate it, and we all appreciate it.
Well, as we said on last night's CBS Evening News, NASA was the can-do agency that worked. It was eager to prove that it still worked, and this morning, so far, it has done exactly that.
I think it's important to remember this is a first step. It's a big first step. We've still got a mission to go ahead of us, and it's also true that one mission doesn't make a space program. We've got a lot of work to get our space program back going, but this is a great way to start.
We'll take a break and come back after these messages.